Hey there, science fans! Have you ever wondered how electricity powers our homes, runs our gadgets, and even makes our hearts beat? It's all thanks to the amazing phenomena of electric current and potential difference. In this exciting exploration, we'll journey into the world of electrical circuits, uncovering the secrets behind these fundamental concepts. We'll keep things simple and fun, using everyday examples to help you grasp the key ideas. Get ready to be electrified as we demystify the fascinating world of electricity. So buckle up, and let's get started on this electrifying adventure. Imagine a river flowing downstream. Now picture tiny particles called electrons moving through a wire just like the water in that river. That's electric current. Electric current is the flow of these tiny charged particles called electrons. These electrons are constantly moving, and their movement creates electricity. We measure electric current in a unit called amperes, or amps for short. The higher the amperage, the more electrons are flowing and the stronger the electric current. Pretty cool, right? Now, let's find out what makes these electrons move in the first place. Remember the flowing river? What makes the water flow? That's right, it's the difference in height. Similarly, potential difference is like the push that makes electrons flow. Potential difference, also called voltage, is the difference in electrical potential energy between 2 points in a circuit. It's this difference in energy that creates the force that drives the electrons through the wire, creating an electric current. We measure potential difference in volts. The higher the voltage, the stronger the push or force, and the greater the potential for current flow. So, just like water needs a height difference to flow, electrons need a potential difference or voltage to move and create electricity. Now let's talk about Ohm's law, named after the brilliant physicist Georg Ohm. Ohm's law is like a magic formula that connects electric current, voltage, and resistance. Resistance is like the friction that opposes the flow of electric current. It's measured in ohms. Ohm's law states that the current flowing through a conductor is directly proportional to the voltage across it, and inversely proportional to the resistance. In simpler words, more voltage means more current, and more resistance means less current. Ohm's law is super important because it helps us understand and predict how electricity will behave in different situations. Section 5. The water flow analogy. Understanding electrical concepts with water. Let's use a water flow analogy to make these concepts crystal clear. Imagine a garden hose connected to a faucet. The amount of water flowing through the hose is like the electric current. The water pressure from the faucet is like the potential difference or voltage. Higher pressure means a stronger push. The width of the hose represents the resistance. A narrower hose offers more resistance to the water flow. So, if you want more water to flow through the hose or more current, you can either increase the water pressure, which means higher voltage, or use a wider hose, which means lower resistance. See how easy that is? The water flow analogy helps us visualize and understand the relationship between current, voltage, and resistance. Section 6. Real-world applications. From light bulbs to smartphones, electric current and potential difference are everywhere in our modern world. They power countless devices and systems that we rely on every day. When you flip a switch, you're creating a potential difference that drives current through the light bulb's filament, causing it to glow. Your smartphone's battery provides the voltage needed to power its circuits and components, allowing you to make calls, browse the internet, and play games. Electric cars use batteries to store electrical energy, which is then converted into mechanical energy to power the motor and make the car move. These are just a few examples of how electric current and potential difference are essential for our modern way of life. Section 7. Safety first. Handling electricity with care. Electricity is powerful, but it can also be dangerous if not handled properly. Here are a few essential safety tips to keep in mind. Never touch exposed wires or electrical components. Always assume that electrical wires and devices are live and dangerous. Use caution around water. Water conducts electricity, so never use electrical appliances near water or with wet hands. Unplug appliances when not in use. This helps prevent electrical fires and conserves energy. Don't overload electrical outlets. Plugging too many devices into a single outlet can overheat the wiring and cause a fire. Remember, safety always comes first when dealing with electricity. Section 8. Conclusion: electricity powers our modern world. Electric current and potential difference are fundamental concepts that underpin our modern world. From powering our homes and devices to enabling life-saving medical equipment, electricity plays a vital role in our lives. By understanding these concepts, we can appreciate the wonders of electricity and use it safely and responsibly. So the next time you flip a switch, charge your phone, or watch TV, remember the amazing science of electric current and potential difference at work. Keep exploring, keep learning, and stay curious about the world around you. Section 9. Fun fact: static electricity and lightning. Have you ever walked across a carpeted floor and gotten a shock when you touched a doorknob? That's static electricity. It's a buildup of electric charge on a surface, and it happens when electrons are transferred from one material to another. And what about lightning? Lightning is a dramatic example of static electricity on a massive scale. It's a giant spark of electricity caused by the discharge of static electricity between clouds, or between a cloud and the ground. Isn't electricity amazing? It's everywhere, from the tiniest spark to the most powerful lightning bolt.